Thank you for joining this lesson. We're going to discuss longitudes and latitudes. And in this lesson, I want us to discuss distance along a small circle. Small circles are circles of latitudes. Remember to subscribe to this channel and also share the link with friends. So what we're going to have, I would like to first of all sketch the sphere of the Earth. If this is the globe, then we are talking of okay, we can have the axis of the Earth. Let me even use a straight line to draw the axis of the Earth. This is the axis of the Earth. Axis of the Earth like that. Then now we can talk of circles due to latitudes, with the main latitude or the reference latitude being the equator. This can be the latitude 0 degrees, equator. Now we can talk of any other latitude. Let's say a latitude on the northern hemisphere, such that a latitude is passing through a point like this. This is a latitude. We can call it a latitude theta. It can be any degrees. In the north. So can we talk about the circle now due to this latitude? Because the circle has to move through the globe like that. That is the circle due to the latitude theta degrees. Now that the latitude or the circle due to the latitude is not having a radius equal to the radius of the globe, then we have to find ways of getting lengths which are across this distance. If it was a longitude like this, we can have a longitude. Like yes, this is a longitude. This is a longitude. So for longitudes, if a point is on a longitude, like from here to a point at this point, we usually use the formula for the length of an arc. Let's say arc AB, and now we use the radius of the Earth, goes from this point to the center, and there is also this point to the center, such that there is an angle here, and the angle is usually the difference in latitudes from 0 degrees to theta. Therefore, this would be theta degrees. So we use for great circles or for arcs within a great circle that is along a longitude, we take the distance in kilometers to be theta over 360 to pi r, where r is the radius of the Earth. Now we are talking across a parallel of a latitude, whereby the radius now for this particular circle, the radius for a particular circle like this has reduced to a certain value here. Now the radius is here, a small or a smaller radius. And how do we calculate it? So what I'll do is this. I will say this is my 0 degrees equator. Then there is a certain now latitude. Let's say theta degrees to the latitude. This is theta degrees to the latitude. This is radius of the Earth, because from where the latitude is passing to the center is the radius. So now we are having a smaller radius here for the small circle. I want us to get this small radius. In this case, we're going to say there is an equivalence such that the radius can also be dropped here. So now with the radius of the Earth and this other smaller radius for the small circle, we can talk of the cosine of theta, whereby theta is the value of the latitude at this point equals to adjacent divided by hypotenuse. And for us to remain with r, now we can conclude that r equals to capital R, the cosine of theta. So that is the value of the small r. Therefore, because it is length of an arc and we have known the value of small radius, now we use the same formula. Distance across a small circle in kilometers will be given by theta over 360, 2 pi r, the cosine of the latitude. In this case, theta is the latitude where the two places are, and theta is the longitude difference. The longitude difference. Because for such a case, longitude difference is going to give us the area, is going to give us the angle at the center. It's going to give us the angle at the center. So I'm taking two places such that a place is here and another place is here at B. Therefore, the angle at the center will be the difference between the longitude of B and the longitude of C. That gives us the angle at the center. So now can we talk of an example? Find the distance from A, let's say a point A, which is 60 degrees in the north, then 40 degrees west, and a point B, which is 60 degrees in the north, and we can have a 60 degrees in the east in kilometers. Then you are given pi as 22 out of 7 and capital R as 6370 kilometers. Those are some constants which more often than not are going to be provided. The solution, we're going to have distance in kilometers being given by theta over 360 2 pi r, the cosine of the latitude. So theta is going to be the longitude difference from 40 degrees in the west to 60 degrees in the east. We have an angle difference of 100 over 360 times 2 times pi times r, 6370, the cosine of 60, because the latitude where the two places are is 60, therefore latitude 60. So now with this we can compute. We use a calculator. We have 100 by 2 by 22 by 6370, the cosine of 60 divided by 360 by 7. So this is going to give me 5561. 5561.11 kilometers. And now we can have distance again in nautical miles, whereby distance in nautical miles is given by 60 times theta, again the cosine of latitude, whereby we need 60 times a theta of 100, then the cosine of 60 degrees. This is going to give us exactly, when we multiply the cosine of 60 by 60 and 100, exactly 3000 nautical miles.